In this video, we are going to understand a very important strategy to write general term for a given sequence. Now, the method which I am going to discuss is one of the best and is not included in most of the books. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top, getting excellent marks and admissions to the best university. Now let's look into the solution of this problem. As I said before, it is a strategy which is not covered in books, and you'll find it very useful for solving any question based on sequences where polynomial is the general equation. Question here is write general term for the following sequence and then write the next term. So let's write down all the terms, right? So the terms which are given to us, let me write down term numbers first. First, second, third, fourth, fifth, and sixth. These are the term numbers, and the terms given to us are 7, 16, 29, 46, 67. We need to get the sixth term from our general term, right? So the standard method is always to find the first difference, right? 16 minus 7 is 9, and 29 minus 16 is 13. 46 minus 29 is 17. 67 minus 46 is 21. So first difference, as you can see, is not constant. Now, if I go for the second difference, what happens? 13 minus 9 is 4, 17 minus 13 is 4, and 21 minus 17 is also 4. So that clearly indicates that the second difference is constant. That means that a quadratic equation is going to provide us the solution, not a linear, it's a non-linear pattern. Perfect. Well, at this stage, if you are not interested in finding a general term, you could actually continue and get the sixth term, right? Not an issue. Now, we have realized that quadratic equation is required. That means x square or n square, the term number, right? So let's now understand how do we get this quadratic equation. So once again, I write down all these terms 1, 2, 3, 4, 5, 6. Sequence given to us is 17, 16, 29, 46, 67. Now, once we say that we are looking for a quadratic equation, that means term number square, right? So let's call this as x square. So if I square 1, I get 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. Clearly, to this x square, we have to add something so that we get our number, right? So what are you adding? To find that, we'll have to subtract, right? So if I subtract from 7, 1, we get 6. And here we get 12, here we get 20, here we get 30. And subtracting here, we get 42. So that means we have to add 6 to 1 so that we get 7. 12 plus 4 will give us 16, 20 plus 9, 29, 30 plus 16, 46. So we have to add something like this. Now, what is this when you write in terms of the term number? So you'll find one of our videos on writing sequence for this also, general term for this. Well, you can see that these are product of numbers, right? So definitely, when we are looking into quadratic relation, x times x times x plus 1, something like that has to be there. So 6 is 2 times 3, 12 is 3 times 4, 20 is 4 times 5, right? So we can rewrite this as 2 times 3, this is 3 times 4, 4 times 5, 5 times 6, 6 times 7. Do you see the pattern? Now, in terms of the term number, 2 is 1 more than 1. So I could write this as x plus 1 times x plus 2 in general, right? So if I put 2 plus 1, we get 3, 3 plus 1, we get 4, right? So it is the product of these consecutive numbers. When you add that to x square, you get your general term, right? And therefore, combining the two, we get our general term. So what is the general term for us? Let's write down. So the general term is addition of the two, x squared plus x plus 1 times x plus 2. So that way you get an equation. So let's take it on the next page. So we got a general term which is x squared plus x plus 1 times x plus 2. This could be good enough to find the sixth term, right? You have an expression. But in case you want to expand and write down the standard form, we can do that also, right? Plus, let's expand this. We get x squared plus 2x plus x plus 2, right? And that gives you 2 times x squared plus 2x plus 1 is 3x plus 2, right? So that becomes the general term for you. Well, if you have this equation, you can find the sixth term. 1, 2, 3, 4, 5. So here, x is equal to 6, right? So we have to find what happens when x equals to 6. So in that case, we get our solution 2 times 6 squared plus 3 times 6 plus 2. 2 times 36, which is 72, plus 18 plus 2, right? Which is 92. 18 plus 2 is 20. So we get the sixth term as 92, and we get our equation, which is the general term, as 2x squared plus 3x plus 2. Makes sense, right? That is how we are going to get the general term for non-linear sequence as shown here. This is a very useful strategy. I hope you have understood it. Now, here is a practice test question for you. So here is another sequence which is non-linear 2, 4, 10, 28, 82. I would like you to find the finite difference. You will see that the third finite difference is constant in this case. Then follow the method which I used and find the solution. I hope it makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.